for us today. As you can see on my screen, I worked out the odds with my other algebra class, so I feel like it'd be great if I did the evens with you guys. All right. Now, for the first set of problems here, though, determine whether each expression is a monomial. All right. And explain your reasoning. Obviously, I don't care about explaining your reasoning, but I know everybody knows what's mono mean, right? Mono just means what? One, right? So monomial just means one term. Now, you might hear the term binomial. Binomial probably means what? Two terms. Trinomial probably means three terms. And when somebody says polynomial, that's many terms. All right? So you have these four terms. Monomial, one term. Binomial, two. Trinomial, three. Polynomial, many. What separates terms? Addition and subtraction. All right, does everybody hear me? Terms are separated by addition and subtraction. Now, there are some basic rules, and as we go through these 6 examples, I will explain exactly what the rules are. All right, so number 1, is that a monomial?
Yes.
Yeah, obviously, it's one term. All right. Number 2, is that a monomial?
No.
No, it's probably called a what? It's called a binomial because the subtraction separates how many terms? 2 terms. Monomial is one term, binomial is 2 terms. Good.
What do you do with the egg? Is it like the same thing with 3? Or does it stick together?
Say it again.
Like for number 2 on like 3A, isn't that 2 terms?
Very, very good question. Multiplication does not separate terms. You hear me? So I could say this. A, B, C, D. How many terms is that?
1.
1. Do you hear me? All right. Multiplication does not separate terms. What separates terms? Addition and subtraction. You hear me on that now, right?
So division.
Well, and that's what we're going to talk to. Division is special. All right. So look at number 3. Most people would consider that a monomial, but listen to me. That is not a monomial because variables are not allowed in the denominator. Variables are not allowed in the denominator. So that is no. Number 3 is a no. Notice what I said. A variable is not allowed in the denominator. So bear with me on that. All right. And then, again, I'm not going to give you a test on definition of monomial, binomial, and trinomial. I just think you should know it. All right. To me, it kind of makes sense. All right. But this is I'm not even sure exactly why. All right. Other than there's the definition. All right. So let's look at number 4. Is that a monomial?
Yes.
Yes, definitely a monomial. What?
So as long as all the like, terms or numbers are together, it's
With multiplication. Exactly correct. All right. As long as multiplication is involved, it's one term. Number 5. Now, that is a monomial, right? And the reason it's a monomial is because 2 is not a variable. Everybody hear me on that? 1/2 times r. The only thing that can't be in the denominator is the variable. The 1/2 is perfectly fine. All right? Is everybody good with that? All right, now let's look at number 6. What is that called again? Binomial. It's called a binomial. Very, very simple. All right? I don't care what the directions are. I think it's more important for you to understand what they mean. All right? Now, the next thing we're going to do is I'm going to now teach you the rules. But again, I want you to tell me that the reason why I was good right now with this section when I was doing algebra was because I could figure out what the rules are. I wasn't good at memorizing. I had to understand everything. All right, that's what I want you to be able to do. For example, somebody tell me, what does x cubed mean? Somebody tell me, what does x cubed actually mean? What does it mean? X times x times x. Beautiful. That's what that means. X times x times x. Now, I want you to look up here. This exponent is a 1, a 1, and a 1. All right, so I'm trying to get you to understand the relationship between the exponents. All right, now, I want someone to tell me, if I said to you, y squared times y cubed. If I said, what is y squared times y cubed, you would tell me, obviously, that's what? Y to the 5th power. Now, how did I know that was so obvious? Because we knew from this example right here, come on, now here's where you're trying to be a better student. What did I do to those exponents to get a 3? You added them. So you went to something that you 100% knew. Now you're applying it to something a little bit more complicated. All right? So the rule is when you multiply variables, what do you do to their exponents? You add them. That's what the rule is. If you forget the rule, then you go back to something that you know, like x cubed, and see how x cubed can be broken down to x times x times x, and then you can see that all I did was add. All right, now I'm going to give you another example. What if I said, what is x squared cubed? All right, what does that mean? What does that actually mean? I'm listening. Wait a minute. What does that mean?
X6.
Well, yeah, but what does that mean?
X cubed. X squared cubed.
That's right. Well, okay.
X squared times x squared.
Yes, that means literally x squared times x squared times x squared. Now, what is x squared times x squared times x squared? X to the 6th. Now, why is that important? Because you just discovered a new rule. Power to power. What do I do? Multiply them together. That's exactly right. Power to power, you multiply them together. All right? Those are the 2 new rules for today. All right?
Can you say the second?
Yeah, whenever you have a power raised to a power, you multiply the exponents. That's the rule. All right, that's the rule. All right, now we're going to go around the room. I'm going to start with Thomas in the back. We're just going to go around the room, and you're going to answer the question to the odds or the evens. Who was listening?
Evens.
Evens. Thank you. For those of you guys who were listening, you can be a better student by listening better. All right, so we're doing the evens, even though I said on the homework we're doing the what? Odds. We're flopping them. All right, tomorrow you're going to do the odds. All right, here we go. Mr. Dan. All right, you are now on question number 8. M to the 4th times m squared, Mr. Dan, is what? Now, what's the rule? When you multiply, what do you do to exponents? Shh. That is correct. M to the 6th. The biggest mistake kids make is they put m to the 8th by accident. What do we do with 4 and 2?
Or you know you have.
There you go. That's what we're talking about. Just write the answer, please. Write the answer. All right? You have lots of time to write the original problem. These are basic problems. All right? So now, I'm up front. Number 10. Tell me what you're thinking. Five times 7.
30 to the 8.
Hold on a second.
Oh.
35, right?
Oh yeah.
Now again, the reason why I'm stopping her there is because don't be confused when I say when I multiply, you add, right? This is still simply what? 5 times 7. This is u to the 4th times u to the 4th. This is v times v to the 3rd. You understand me, right? So you multiply numbers, and then tell me what the variable would be.
8.
U to the 8th. And then what? V to the V to the what? Well, what's this number right here? Shh. And what's this number right here? Yep.
4.
Yes, v to the 4th. Remember, the 1 is not there. So sometimes it's easier to just go ahead and put the 1 there. Does everybody see what I'm saying? This 1 right there. Now, don't turn your nose up. If you don't know something, put your hand up in the air and say, give me a little help here, man. Go. Well, what's 5 times 7? You see what I'm saying, right? It's confusing, right? But you still do the same operations with numbers. 7 times 5, 35. But the rules for exponents are different than numbers. You with me now, right? Go.
So if it's different numbers, you always have to do it.
Yeah, because that's what it says, 5 times 7. Right? But if I said what's u to the 4th times u to the 8th, it's not u to the 16th. Right? The rule is you add exponents. Next, number 12. Yep, me, you're up.
It's x, y to the 24.
Okay, now here's what common mistake. There's a 1 there, right? So it'd be x to the what? What am I doing? This
Into the 5th.
times that. Yes. Right? So come on. Collect your thoughts and make sure you're understanding me. Do you understand that now, right? Because there's a 1 here. There's an understood 1. And there's a 6. Power to power you multiply. Correct?
Why do you do it times the 4?
I did. 4 times 6, 24.
No, 4 times.
Okay, let me show you what that means, okay? That's a really important question. All right, so watch this, guys. I want to erase. Everybody look up, please. Look up, look up, look up. And this is what I'm saying is logical to me. All right, this is what I want you to see it as. You hear me? So watch this. That's what that means. Did that make any sense what I just did? Because what? It's x, y to the 4th. What? How many times? Shh. I'm trying to help her. How many times? 6. So look right here. 1, 2, 3, 4, 5, 6. You hear what I just did? And so how many x's are there? 6, because there is a 1 there. You hear what I'm saying? 1, 2, 3, 4, 5, 6, right? Now I'm looking at the y's. 4, 8, 12, 16, 20, 24. Or we could just say 6 times 4. You with me now? All right, so there's 2 great ways, 2 great explanations of how you should and why you should understand that. What? Just a minute. Because it's like, what number's in front of the x? A 1. If I just write x down, there's a 1 in front. You hear me? There's also what?
So,
The exponent is a 1 also.
so they're like always.
If there's no number, it's a 1. Good question. Yes, sir.
Why would you do x? Why wouldn't you just add x and 1, 1 and 4?
I'm agreeing with you. Sometimes I used to say the same thing.
So do you just do it because you get like really?
No, because look, there are what I'm trying to demonstrate to you is that problem is this is created this way. Do you understand what I'm saying? In other words, what I'm trying to get you to see is x, y to the 4th to the 6th is what that means. You see what I'm saying, right? So there are these values here are all 1, which gives me an answer of x to the 6th. All right, hopefully you understand that. All right, carrying on. Here we go. After 12, 14. All right. Carter, you're up. 14. What's negative 2 times negative 2 times negative 2?
No.
Negative 8. F to the what power? F to the what? 6th. G to the what? H to the what? Now you're supposed to ask me if you don't know. What?
How do you get negative?
Negative 2 cubed. What does negative 2 cubed mean? Negative 2 times negative 2. I know, that's the problem. You're training your brain. You multiply variables, right? You don't multiply a number to its power. That's never going to work. What, Joseph?
You get like the 6 and then
What did I do with this 2 right here and this 3? That's right. What did I do with this 3 and this 3? What did I do with this 2 and this 3? Yes, sir. You hear me now, right? Grace, you good now or not?
Oh, yeah, that was
All right, here we go. Now I'm on 16. Yeah, I don't care about 16. Cross out 16 for now. All right, wow. Okay, 18. I've got some problems here. All right, so Grayson, a little bit complicated. All right, so what you're going to do is you're going to tell me what is this answer right here.
So it's, is it negative 9 or negative 6?
No, negative 3 times negative 3. Negative times a negative is always a what?
So
Yes or no?
9.
Yes. 9, D to the F to the
6.
G to the, beautiful. All right. Now, Miss Hulsman, times your job now is to do this. All right. Now we have a problem. So let's look right here, Miss Hulsman. You see where it says power to a power. What do you do to that? That's right. So now I'm going to do this for you. And if you're not sure, you tell me. Parentheses. You understand that? All right. Now, everybody take out the calculator. All right. I'm not expecting you to know 3 to the 6th is 729. All right, but take out your calculator because we're going to show you that. What? Come on, speak up. I'm not done yet. All I did was, do you see this power to a power? So that makes it 6. Now we're working on this. Great. Mia's going to work on this. All right, so now on your calculator, if you don't put it in parentheses, it's going to be wrong. Parentheses, negative 3, close parentheses, to the 6th power. And hopefully you get 729. Am I right, Miss Hulsman?
How do you do 6?
You do the caret button. This button right there on your calculator.
What do we get?
Shh. Caret. You see it? So it's going to be parentheses, negative 3, caret 6. You see the caret button or not? What'd you get? Hopefully 729.
Yeah.
All right. So this will be times 729. Now, Miss Hulsman, what is D to what power? But we're raising, yes, there you go, girl. 12. F to the what power? This is, yes. Beautiful. And like I said, most people forget there's a 1 there. All right, now I'm going to bring down the 9, D to the 4th, F to the 6th, G squared. What?
739 negative.
Well, if you didn't put a parentheses around it, yes, it is. If you put a parentheses around it, no, it's not.
I said correct.
No, you didn't. You didn't do negative 3, put a parentheses, shh, parentheses, negative 3, close parentheses, caret 6. Hey, Yosef, listen to me. Look up. You see what I'm saying? Look up on the board. I gave this how I wanted you to type it in your calculator. Right? You see what I'm saying, right? That's called listening. You hear me? Get better at it. All right? You can do that. So you're clear on that now, right?
Yeah.
Good. All right? You with me still? All right. What?
How'd you get 90 again?
How did I get what?
90.
It's okay. Look right here, kiddo. You ready? I'm gonna try to highlight something for you, different color. -3 squared. -3 times -3 is 9. That's a big mistake, right? Because a power to an exponent is different than a variable to an exponent. You hear what I'm saying, right? All right. So now we're over here. You're up. Now, what do I do for the final ant? Is that us?
Yes.
Okay. So guys, listen to me. Do what you can. Go down. Do what you can on the evens. All right. Try to do the evens. Whatever you can. All right. We were a little slow today because I had to give out grades. Tomorrow I'll spend more time. Again, do what you can do. All right. You should. And the solutions are posted. All right. So look at the example prompts. If you're going, I'm confused, read the explanations. All right. That was good. All right. Good job.